Thank you for joining this lesson. We're going to discuss linear programming number 23. We are told that a certain uniform supplier is required to supply two types of shirts, one for girls labeled G and the other for boys labeled B. The total number of shirts must not be more than 400. He has to supply more of type G than of type B. However, the number of type G shirts must not be more than 300, and the number of type B shirts must not be less than 80. By taking X to be the number of type G shirts and Y the number of type B shirts, part A, write down in terms of X and Y all the inequalities representing the information above. Remember to subscribe to this channel and also to share this link with friends. A certain uniform supplier, I'm rereading the question so that you may extract the inequalities, is required to supply two types of shirts, one for girls labeled G and the other for boys labeled B. Now the total number of shirts, remember the number of shirts of girls has now been abbreviated using X and that of boys using Y. So the total number of shirts must not be more than 400. That is the first instruction. The total number of shirts must not be more than 400. So the total number means when we take X and we add Y, that is the total number of shirts, must not be more than 400. Must not be more than 400. So the highest they can go is 400. So that means they are less than 400, but they can be still 400 because we are told they must not be more than 500. So they can be 400, but not more than. This becomes our first inequality according to that instruction. The next, he has to supply more of type G than type B. Therefore, type G, that is for girls and is represented by X, must be greater than Y. This is another inequality. We don't have to include or equal to because they must be strictly greater than Y. That becomes our second inequality. And now we are told further that, however, the number of type G must not be more than 300. Type G, that is for the girls, which is X, must not be more than 300. So the highest they can be is 300. So either 300 or below that, but they can be. So that's why we have or equal to. So they should be less than 300 or equal to 300 because the highest they can be is 300, must not be more than. So the maximum they can be is 300 or below. This becomes my third inequality. We can continue interpreting these informations. And the number of type B, must not be less than 80. So for B, which is now Y, must not be less than 80. Must not be less than 80. So they can be 80, but not below that. So they're supposed to be above 80. They are supposed to be above 80. Must not be less than 80. So they can be 80 or beyond that. This becomes my fourth inequality. So we have now our inequalities here, and we are told on the grid provided, draw the inequalities and shade the unwanted regions. Draw the inequalities. So the inequalities now are supposed to be drawn, and we usually change the inequalities to borderlines by the time we are drawing them, such that instead of the inequality symbols, we use equal signs to change inequalities into borderlines. Therefore, I'm going to first of all come up with the borderlines. Now, the respective borderlines. For number 1, we're going to have x plus y being equal to 400. This becomes the first borderline. And this borderline will require a table of values, x and y. If we let x to be 50, for example, the value of y is going to be 400 minus 50 to give us 350. If the value of x becomes 100, the value of y is going to be, we subtract 100 here, 300, and such. So this is how the table is supposed to be. The next is x greater than y. So x equals to y. This becomes our second borderline. The third borderline becomes x equals to 300. And the last one, whereby it's y greater than or equal to 80. Now y becomes 80. So this is the third, this is the fourth. So now instead of inequalities, we shall plot these borderlines. We shall plot the borderlines. So let me draw the vertical axis. Let me also come up with an horizontal axis here. An horizontal axis. Then now I can use a range of 50 so that I go to 100, 150, 200, 250, 300, 350, 400, 450, and such. The next one I can begin with 50, 100, 150, 200, 250, 300, 350, 400. So this is now what we are calling the Cartesian plane, already labeled. We can begin with the first borderline, whereby we are saying when x is 50, y is 350. So I can begin with 50, 350. This is the first coordinate. 100, 300, 100, 300. That means if we continue in this table to see what it will be at 200, then the value of y is also going to be 200, because we will subtract the 200 here. So 200, 200, 200, 200. So those are some of the coordinates for that borderline. And something else we should consider, because there is the symbol or greater than, then we need to have it as a complete line. The line is supposed to be complete and not dotted. The line is supposed to be complete and not dotted. So allow me now to draw this line. Allow me come up with this borderline. Which must be complete. That is the first borderline. The borderline which can be labeled to be y plus x equals to 400. That is the borderline. Y plus x equals to 400. The next borderline is x equals to y. X equals to y. When x is 50, y is 50. When x is 100, y is 100. When 150, the other one is also 150. So that is how we come up with the line y equals to x. So as a borderline, we're going to have it, because we are told y must be greater than, x must be greater than y. X must be greater than y and not equal to, then that borderline is supposed to be dotted. The borderline is supposed to be dotted. So standing here, I'll do a dotted line through those coordinates. So this is the borderline, which is dotted, or rather broken. X equals to y, or rather y equals to x. It's all the same. That is the borderline. The third borderline is x equals to 300. X equals to 300. For such a borderline, it's good to remember that there is or equal to. So for x equals to 300, the line has to be complete. The line has to be complete. X equals to 300, the line has to be complete. So I use a complete line at this point. I use a complete line. Complete line. This is line x equals to 300. X equals to 300. This is the borderline. X equals to 300. The last borderline is borderline y equals to 80. Now, for that one, we're also having or equal to at the inequality. After knowing the borderline, we go back to the inequality to see whether there is or equal to, so that you may know the kind of a line. So the borderline at y equals to 80 must be complete. Y equals to 80. This is 50, this is 100. So at a point here, that is y equals to 80. That is y equals to 80. So I draw this line now. Yes. So this is y equals to 80. Now with all the borderlines, we can see the common region is here because it has been bordered by this line. So we shade the other sides now. It means we are also going to shade this side. It means for this one, we are shading this side. And for this one, we are shading this side. This is the side we are shading. So now when we shade like that, we come up with the desired region in such a manner. With the desired region, now it is good to know that all the fixed coordinates within the required region are lying on a complete line. Those must be instructions. All the points, all the integral coordinates, either within the region or lying on a complete line, which is not dotted, symbolize the number of shirts which can be bought. The combination. If it's a coordinate like this, for example, this is a coordinate 200, 150. That is a possible combination of a certain number of shirts which can be bought or brought by this supplier. So the possible number of shirts which can be bought are going to be regions like this. This coordinate, this coordinate, this coordinate, this one because it's lying on a required line, this coordinate, it is on a complete line, and this one also, it's on a complete line. This one also, it's on a complete line. This one. Okay, so there are several. The ones lying on this line cannot be picked. The ones on that line cannot be picked. Let's go now to, part C. given that type G costs 500 per shirt and type B costs 300 per shirt. Part 1, use the graph in B to determine the number of shirts each type that should be made to maximize profit. So there is a certain combination of number of shirts that when the supplier brings that, he or she will make maximum profit. Maximum profit. Therefore, what do we do here? We're going to look at the combination that is having the highest number of the G shirts, which are the X. So the combinations within the required region whereby the value of X is the greatest. So these are combinations. The value of X here is 200. The value of X here is 250. Now the value of X at this point is 300. So this coordinate, which is 300, remember this is 380. 300 for Y, 80 for X. 300 for X, sorry, 80 for Y. But this one is still a possible combination, but it's 300 coupled with 100. So that becomes our favorite combination, where the one having a bigger cost is having the highest value. So all these are possible values, but now we want where the value of X becomes greatest, because X is having a higher price. So where the value of X becomes greatest is at 300. But now we have several combinations of 300, and the biggest one is this one. The biggest is this one, because here 300 has been combined with 100. So 300 and 100, this is X, this is Y. So we need 300 for G and 100 for Y. They are going to give us the maximum profit. Then finally calculate the maximum profit, the maximum possible profit. So 300 for X, each costing 500, and we add 100 for Y, each costing 300. We're going to get 15,000 and this is a 150,000 and 30,000. So 180,000. 180,000 Kenya shillings. We can have other combinations, but this one is giving us the maximum profit. Thank you for following. Subscribe and share.